Okay, so the other day when we had fractions that had radicals in it, we just multiplied, especially if it was a square root, we just multiplied it by itself. If you remember, we had, I don't know, something to the effect of like 2 over the square root of 3. And then to get rid of that radical, we just multiplied the top and the bottom by the square root of 3, right? You guys remember doing that? Okay. Why are these a little bit different? Look at your denominator. How many terms does it have now? It has 2. So multiplying by just the radical is not going to get rid of the square roots in the denominator. So what we're going to have to use is the idea that we talked about yesterday, the conjugates. And those are going to be exactly the same, except for you're going to change that middle sign. And to do that, we multiply the top and the bottom by the conjugate, and that will allow us to get rid of our radical. So if I'm looking at my denominator only, if it is 2 plus the square root of 3, what would the conjugate of that be? 2 minus the square root of 3. So what we're going to do is we're going to multiply the top and the bottom by 2 minus the square root of 3. You don't have to put parentheses around it. I like to because it just makes it look better to me when we start multiplying everything out, especially when you have a binomial times a binomial. So what we're going to do now is we're going to take this 7 in the numerator and we're going to multiply it by both terms. We multiply it by the 2 and we multiply it by that square root of 3. Okay, so I get 14 minus 7 square roots of 3 at the top. And then at the bottom, I have to multiply those 2 binomials just like we did yesterday. If it helps you, makes it look better, like I think it does, put parentheses around it so then we can FOIL. So we're going to start just like we did yesterday. We go 2 times 2, which gives us 4. 2 times a negative square root of 3, which is a negative 2 square roots of 3. A positive square root of 3 times 2 is a positive 2 square roots of 3. And then a square root of 3 and a negative square root of 3 gives me a negative square root of 9. Okay, so all I did was FOIL that denominator just like we multiplied yesterday. Then we're going to combine all like terms, and then at the end we just check to see if we can simplify. So I'm going to start by getting rid of what perfect square can be simplified right now? That 9. That 9 is going to turn into just 3, right? So at the top I'm going to leave it alone for right now because there are no like terms up there that I can combine. At the bottom, now that my perfect square is gone and turned into a whole number, I can combine those terms. So we're going to go 4 minus 3. What does that give me? 1. And then my 2 middle terms are always going to do what? Cancel out. Okay, they should if you multiplied correctly. And then I would try to simplify. However, the only way you can simplify these is if the number in front of the radical, and the denominator all have something in common. If they don't all 3 have something in common, then we cannot simplify. Okay, not just 2 of them, but all 3 have to have something in common. And if we look at it, 14, 7, and 1 don't have anything in common besides 1, do they? So you can leave your answer like that, as 14 minus 7 square roots of 3 over 1, or how else could we just write it? Yeah, we could just write it as 14 minus 7 square roots of 3. I would take either one of those. If you want to leave it over 1, you're welcome to. If you don't want to, that's fine too. Does that make a little bit of sense? Now, with number 2, we're going to do exactly the same, but usually if I put a negative in front of my first term in that denominator, people try to change that. The only sign you want to change for the conjugate is the middle one. So if my denominator is negative 6 minus the square root of 2, what would the conjugate be? Negative 6 plus the square root of 2. Yeah, you don't change the sign in front of the first term. You only change that middle sign. So I want to give you just a minute to work that out. Okay. Go ahead and multiply at the top. Multiply at the bottom. All right, so at the top, I'm going to take the 6 and multiply it by each term. So that's going to give me negative 36 and a positive 6 square roots of 2. And then I'm going to do the same thing at the bottom. I'm going to distribute, starting with this negative 6. It gets multiplied by both terms in the second. Then I multiply the negative square root of 2 by both terms. Negative times a negative is going to turn positive. And a negative square root of 2 times a positive square root of 2, maybe, is going to be a negative square root of 4. And again, I'm going to get rid of my perfect square first. That's going to turn into a 2. At the top, I'm leaving everything the same for now. At the bottom, what is 36 minus 2? 34. And then are my middle terms going to cancel? Yes, okay. Here's a little shortcut you can do. When you're multiplying your denominators by conjugates, your middle terms always cancel. So what you could do, if you wanted to, just to save a little bit of time, I'm just going to show you the bottom part. What you could do, since your middle terms will always cancel, it could save you a little bit of time if you just multiply the first two and then the last two, because those middle terms are going to cancel either anyway. So what's the point in writing them down, right, if you remember that? Okay. You don't have to do that. I'm just saying you can. Now let's look at all three numbers. We're looking at the first term at the top, the number in front of the square root, and then the denominator. Can all three of those divide by something? Yeah, they can all divide by 2, right? They're all even. So what is negative 36 divided by 2? Negative 18. And 6 divided by 2 is 3. You don't touch the number under the radical. It stays the same. And then 34 divided by 2 is 17. And that would be how we leave our most simplified answer. Okay, again, all three of those terms have to have something in common for me to be able to simplify. Not just 2 of them, but all 3. Anybody have any questions so far? Okay. All right, let's take a look then. Actually, I want you to try both of those. All right, if I start with number 3, what is the conjugate of my denominator? The square root of 2 plus the square root of 7? Okay. All right, so we're going to multiply at the top. The square root of 5 times the square root of 2 is the square root of 10. The square root of 5 times the square root of 7 is the square root of 35. At the bottom, square root of 2 times the square root of 2 is the square root of 4. Again, we cannot do our middle terms if you want to. I'm going to go ahead and do it because I don't want to confuse anybody. That's going to give me the square root of 14. That's a negative square root of 14. And then that is a negative square root of 49. This 4 is going to turn into 2. That 49 is going to turn into 7. What do those middle terms do? Cancel. So at the top, we have the square root of 10 plus the square root of 35. At the bottom, we have 2 minus 7, which gives me a negative 5. Can any of that simplify? No, because I don't have the numbers in front of my radicals, okay, are just 1 and 1, and my denominator is 5. I cannot simplify anything there. Does 10 or 35 have a perfect square in it that I could simplify a little further? No. So we can leave our answer just like that. Is everybody okay with that one? All right, what's the conjugate for number 4? The square root of 5 minus 1, the conjugate would be the square root of 5 plus 1. All right, so at the top, that's going to give me 4 square roots of 25 plus 4 square roots of 5. And at the bottom, that's going to be the square root of 25 plus the square root of 5. Whoops. Minus the square root of 5, minus 1. Do you notice how this time we have a perfect square in the top too? We're going to keep that 4. What's the square root of 25 turn into? 5. All right, at the bottom, the square root of 25 turns to 5. My middle terms cancel each other out. So I'm going to get 20 plus 4 square roots of 5 over 4. Look at your 3 numbers. What can they all divide by? 4. So that's going to turn into 5 plus 1 square root of 5. You can put a 1 in front of it if you want to. You don't really have to. And that's over 1. You can leave your answer just like that. Or we could also just write it as 5 plus the square root of 5. Do I have any questions? Okay, I got a couple people writing, so I'm going to wait just a minute. They don't really get much harder than this. They get a little bit longer if I put a binomial in the numerator as well. That just means you have a little bit more to multiply. So let's take a look at 5. If you'll take a minute and write it down, we're going to work through this together, and then I'll let you try 6, and these will be our last 2. The only difference between these 2 and the first 4 that we did is my numerator has a binomial as well. That doesn't change the process. We still want to multiply the top and the bottom by the conjugate of the denominator. If my denominator is 5 plus the square root of 3, what would the conjugate of that be? 5 minus. Okay, so that's what we're going to multiply the top and the bottom by, is 5 minus the square root of 3. And again, I like to add the parentheses just because it, to me, makes it look better when I multiply. So start at your top. Go ahead and FOIL out those 2 binomials. You want to multiply 2 minus the square root of 3 times 5 minus the square root of 3. Once you do that, then you can multiply the denominators. Then you're going to want to combine all the like terms you can after you get rid of your perfect squares. And then lastly, check to see if you can simplify. Start by foiling the numerator. Then we FOIL the denominator. Do you guys see the 2 perfect squares in the top and the bottom that I can simplify? All right, both of them are going to turn into just 3. So at the top, my 2 terms that don't have radicals are 10 plus 3, which gives me 13. Do these middle terms cancel out in the numerator, though? No. What's a negative 2 and a negative 5 give me? Negative 7 square roots of 3. Then at the bottom, I've got 25 minus 3, which is 22. And these middle terms, they do cancel, right, because they're conjugates? And then I'm going to check my 3 numbers, 13, 7, and 22. Do those all have something in common? No. So I'm going to leave my answer just like that. Does that make a little bit of sense? All right, go ahead and try 6 then. All right, if I'm multiplying by the conjugate of the denominator, what is the conjugate of the square root of 6 minus 1? And we're going to multiply the top and the bottom by that. So let's see, square root of 6 times the square root of 6 is the square root of 36. That's plus the square root of 6. That's plus 4 square roots of 6, and that's plus 4. And then into the denominator, that is the square root of 36 plus the square root of 6 minus the square root of 6, minus 1. And then I've got a couple of perfect squares I'm going to go ahead and simplify. And then we combine our terms at the top. What is 6 plus 4? 10. And then 1 square root of 6 plus 4 square roots of 6 is In the bottom, 6 minus 1 is 5, and then those middle terms are going to cancel each other out just like they should. And then looking at my three numbers, 10, 5, and 5, do they all have something in common? Yes. What can we divide by? So that's going to turn into 2 plus 1 square root of 6 over 1, which is really just 2 plus the square root of 6, right? Is everybody okay with that? One thing I do want to tell you before I let you get on your homework, let's say, for example, I had something like this, okay? When I multiplied it out and combined my like terms. When I divide, no, that doesn't work. Hold on, let me change this just a bit. Okay, let's take a look at our numbers. The first number 4, the number in front of my radical 8, and the denominator, they are all divisible by what? 4. When you do this, remember, if I take and divide 4 by 4, it doesn't disappear. What does it turn to? 1. So you have to put a 1 up front, and then you would divide the 8 by the 4 as well, and that would turn into 2 square roots of 3, okay? So if that first number is completely going to disappear, it doesn't really disappear. It just turns to 1, so don't leave that off if you run into a situation like that. Is everybody okay with that?